Okay, so to start this video, we're obviously going to cover, first off, what is a limit. And there's a really confusing fancy definition of a limit, but essentially all a limit is what a function is approaching as its input is also approaching a value. So like, for example, if we had a function that looked like this, and we had a point right here, and the y-coordinate of this point was, 5. And the x-coordinate of this point was 6. And this is, let's say, f of x. Then the limit as x approaches 6 of f of x is going to equal 5, because both the left side and the right side of this function are approaching 5 as the x-coordinate is approaching 6 from both the left and the right. And so that's essentially what a limit is, just what a function is approaching as the input, which is usually the x-coordinate, is approaching a certain value. Now, that doesn't mean that the limit always exists for all functions. There are a bunch of times when limits don't exist. So, for example, let's say we had a function, and our function looked like, we'll put this here, looked like this. And this right here is our x-coordinate of 6. And this right here is our x-coordinate of 4. And this right here is 5. Or something like that. Let's say we had a function that looked like this. Now, what is the limit as f of x approaches 6? Well, as x approaches 6 of f of x. So you might think, well, as the function approaches 6, the value of the function is actually 4, right? Because an open circle means there's nothing, the function isn't actually at 5, it's at 4. But the limit isn't actually at 4. Because when we consider limits, we always have to consider what the function is approaching from both the left and the right. It's not just what the function is at, otherwise this would just be f of 6. This is not equal to f of 6. So from the left-hand side, which we'll write like this, the limit of x approaches 6 from the left-hand side of f of x. From the left-hand side, this is clearly approaching 4. But from the right-hand side, which we write with a little positive sign in lieu of this negative side of f of x, this is approaching 5. Now, these two are not equal, and so we can say that since the left-hand side of this limit and the right-hand side of this limit are not equal, the limit at this x-coordinate does not exist. Now, there are a few other scenarios when limits don't exist. A big one being asymptotes. Now, a lot of times people will think about this as like the limit is approaching infinity. But when limits approach infinity, they don't actually exist because infinity isn't really a number. So, like, let's say this was 7, and this is g of x. So, the limit as x approaches 7 of g of x. Now, technically, yes, the left side is approaching infinity. It's going up. It's approaching an infinite value. I guess we could say it's getting infinitely larger. And the right side is also getting infinitely larger. So, a lot of times you'll see this written as infinity, right? And that's not really accurate because infinity isn't a real number, but a lot of times people will write this like this. So if you see this, don't be super thrown off. It's just saying that essentially there's just a vertical asymptote at x equals 7, meaning the left side and the right side at 7 approach an infinite value. But, technically this limit does not exist. You'll just see it written like this sometimes. Or if both sides were instead, let's have this go downwards here, and let's say this is at the x-coordinate of 15. Maybe I should erase these little thingies. We could say that the limit as x approaches 15 for g of x is equal to negative infinity because both the left side and the right side are approaching negative infinity. And again, this is so important. You have to make sure that both the left and right side are approaching negative infinity. And so this would sometimes be written as negative infinity. But in this case, there's one other case where it's an asymptote, but you can definitely say the limit does not exist. There is no possible way you'd write it with infinity. If you had a limit that looked like this, we can make this at the x-coordinate of 4, and then it went like this. Well, now the limit is approaching, from the left side, it's approaching positive infinity, and from the right side, it's approaching negative infinity. And let's say this is h of x. So we would say that the limit as x approaches 4 from the negative side of h of x, this equals positive infinity, while the limit as x approaches 4 from the right side of h of x equals negative infinity. And since these two are not equal, the limit does not exist. There's no way to write it as either infinity or negative infinity, so you just got to be careful. And as for how you know, I mean, you're not going to graph out the function every time. So there are a lot of strategies for solving limits. But this is just the basics you got to know. In terms of when the limit doesn't exist, there's one more main situation that is mostly talked about, and that's when a function is oscillating. So for example, in the example of cosine of 1 over x, this graph, and I know I'm not going to draw it perfectly, right? But this graph is going to just infinitely oscillate. And it's not like the graph of cosine or sine. You know what? Actually, let me look this graph up in Desmos and get right back to you in a second. But it's not like the graph of cosine and sine, because those oscillate at a constant rate. You can tell their periods, and they'll be the same sort of interval every time. The distance from here to here is going to be the same as the distance from here to here, at least theoretically. For something like sine. But for something like cosine of 1 over x, this is not going to be like the same period with every oscillation. So if the function is oscillating like infinitely as it's approaching a point, then there's not going to be a limit there. And this is, I recognize, a really bad drawing. Let me get a Desmos image for you 1 second. Okay, here it is. Look at this. What is this? Like, there's no way this function is approaching anything specifically, because like every 10th and every 100th and then every like 1/1,000,000th of a unit, the y-coordinate is drastically changing. Like, we cannot say that this function is approaching anything. It's just oscillating back and forth. So this is what I mean when I say oscillating functions, like at 0, this would have no limit, just because it's just constantly changing. It's not approaching anything. And so yeah, that's basically it. But one more thing I definitely want to touch on before I end this video is that a function does not have to be defined at a point for the limit to exist. It doesn't have to be continuous at that point. And let me just review again what continuity is. Continuity. The simplest way to define it, as a math teacher last year described it to me, is if you can draw a function without lifting up your pen or your pencil, it's continuous. Like, for example, I just drew that without lifting up my pen. It's a continuous function. But if I were to draw something like this, you know, with a giant jump in the middle, I lifted up my pen, well, now it's not continuous. So an important thing to note is if we have a function like this, and it has a hole here, meaning there's no value at the coordinate of x equals 3, and then it just keeps on going, so it's not defined at x equals 3, so we can say, like, k of 3, it's not defined. DNE, it does not exist. That's not defined. The limit can still exist at 3 because if you notice, from the left side and the right side, the function is still approaching 3. And so in that case, the limit would still exist even though the function isn't defined at 3 and there's a discontinuity at 3. One more thing, is that a lot of times questions will ask you for one-sided limits, and all that is what a function is approaching from that side. So if that particular side, so like this limit right here does not exist, but the one-sided limit of this function from the left would be represented like with the little negative sign here. This would be the one-sided limit at 4, and this would be another one-sided limit except from the right side, the other side. So if they ask you for a one-sided limit, it's just whatever the function is approaching from that side. So you can have a scenario where a one-sided limit exists, but the limit at that point does not exist, so you just have to be really careful, with just the wording of the question.